So this is the pressure at outer region. So we are supposed to import this pressure in the static structural part. So I'll set up. I'll give the same geometry. So I'm importing the same geometry to the static structural part in the engineering data. General non-linear material, because our blank has to permanently deform. That's the reason non-linear metal. I'll go with aluminum alloy. Aluminum alloy. Under geometry, same geometry. So directly go with the model. So here under geometry, I'll just suppress this body because we don't need fluid geometry here. So this is die, blank, punch, and blank holder. So I'll assign the same for blank. I'll assign blank holder. Sorry, aluminum alloy for blank. Aluminum alloy for blank. So all these are flexible. So I'll make it rigid. Die, die, punch, blank. I'm setting to rigid. So these all are rigid. So we will be seeing the deformation in the blank part only. So now contacts, delete the contacts. Manual contact. Contact. This one is a contact surface. And this one is the target surface. Bonded. Same. Now let's create the contact between blank and the blank holder. So the contact. This is the target. Now we'll create between blank and the punch. So this is the blank contact. So all this contact part, all this contact why we have to give contact, all those things has been explained in the deep drawing video. Link will be in the comment section. Please do check it out. So changing from all this bonded type to frictional type. So here interface treatment, adjust to touch, formulation, augmented Lagrange, and the friction. Before friction, we have this involved radius 5 mm, small body, blank to punch. Friction is 0.14, and this for these two friction is 4e minus 2. Stiffness, normal stiffness factor 0.1. So now machine sizing for the whole body, generate mesh. So the only sizing is given to this plank because all the remaining solid structures are rigid bodies. So we are going with the default mesh. And since this is a punch, blank holder, die, all are rigid body except for blank. So the mesh is generated only where the contact is established, where the contact is there. So wherever the contact we have given, only at those area there is mesh. This was a target. 1, 2, 3. 1, 2, 3, 3. Three faces. Okay. Again, generate mesh. Now it is okay. Show all bodies. So now the mesh is regular mesh. So now we'll implode the pressure. From the inlet region. So what are the pressure at the inlet region is there? So same pressure will be imported to this area. So next, this region, apply. This one is from outer region. Outer region. So I'll import the load. So now this is the pressure at the inlet from inlet region, and this is the outer pressure from outer region. From outer region. So Ansys setting and number of steps 10. Number of steps 10. Auto time step. Select all steps on sub steps. Initial 60, 60, 40, 100. So now for 7, 8, 9, 10, initial step 100, 50, and 150. So 60, 40, 100, 100, 50, 150. Okay. Roll body. So now we'll give our displacement, remote displacement. Apply. X component is constant, that is 0. So no movement in the X component. And this is tabular, constant, constant, constant. So this Y component, so it's a negative 50. The force has to act negative downward direction, minus 50. So this one, minus 5. So 0, minus 5, 10, 11. So 5 mm increment at each step. Okay, now we again have to remote displacement. Same remote displacement. So this one for blank holder. So it is fixed in position. So constant 0, 0, 0, 0, 0. So 0, 0, 0, 0, 0. No movement at all. Now for this space 0, 0, 0, 0, 0, 0. So if I go on contact tool and generate initial information, I'll get this one. The orange means the status is closed but has a large amount of gap or penetration. This gap is the, the gap it is considering is talking about this gap. The geometry part, we have this huge gap where 2 mm outlet of this fluid medium was supposed to be there, but we suppressed it. This fluid part was there, and since we removed it from our simulation, so hence there is a large gap. So that is what it is talking about, this contact. So remaining other two contact is good. The only one contact, it has the issue with the large gap. So now we can also remove this gap, like we can displace it downward. The gap is 2 mm gap. Since I have the gap is 2 mm gap, so we can move this 2 mm gap. So it's like just like doing structural analysis for deep drawing without fluid domain. So this gap, we can if you have seen the deep drawing video, there won't be any gap. So we can use that geometry as well, because now the only thing we wanted is to apply pressure on the bottom side of this blank. So that pressure, with irrespective of the gap, the pressure will be applied. So we don't need to have a gap in this one. So one can use it or choose not to use it. It depends on the user. So, but I am just keeping it that way, and that is the reason we have this orange indication that we have a large amount of gap. You will get the same result if you don't prefer that gap. So no changes in the result. Strain equivalent plastic thread, stress equivalent one necessary, directional deformation, one necessary, not for all body, only for this single body, which is flexible, remaining all are rigid. For this directional deformation orientation, x-axis changing to y-axis. Large deformation, sorry, deflection. One, angle, load step, all, substep last. So now we'll give symmetric condition, symmetric, symmetric region. So this one, normal to z-axis. So changing x-axis to z-axis. So normal to z-axis. This one is normal to z-axis. Now another one, this face. This face is normal to x-axis. X-axis. Okay. Now solve. Force convergence. Okay, now the simulation has completed. So this is our deformed blank. Directional deformation minus 50 mm.